This is lesson number 12 in Algebra 1, and today we're doing the classic stacking cups problem, and we're going to approach it a few ways. And we're also going to do a very quick activity using GeoGebra and a linear model problems. So let's start with the stacking cups activity. Now the first activity was done by Dan Meyer way back in 2008. And there are so many variations of this on the web. I'm sure you can find dozens more. But this is the original and probably the best. It's very simple, and that's what makes it so good, in my opinion. And it doesn't give the kids a lot of things up front. You basically solicit questions from your kids and let their questions drive the instruction and drive this lesson. Now, depending on your kids and their sophistication, some of them will fly through this because they will notice things so fast, and then you've got other groups that don't. So this is definitely something you would cater to your group. But I would read every word on this blog because this is the foundation of inquiry. This is how it's done, and it's probably it's a really good example of how it's done. But he would basically do something to get the kids' attention, and he has these stack of cups. How many of these to get to my height? And so you could ask something like that. You could ask how many to get to the height of something they can't actually see, like the top of like the Empire State Building or the Statue of Liberty or something like that. So you could create something of your own out of this if you want. But he talks about the process, and the kids actually need to be given some kind of ruler or measuring device. He does use centimeters to measure, so you may want to tell them up front what unit to look at if you have a preference. And then you're going to have them come up with a graph and an equation that will actually stack the cups, actually measure the cups, and then he has an extension here. And then he has two different kinds of cups. So, I mean, he's got a lot of information here. Now, there's lots of comments. Of course, people that don't like inquiry are going to jump in there and criticize. But if you've never tried any activities like this in your class, this is a good one to start with. The standard styrofoam cups are excellent because they have a large lip on them. So there's a significant rate of change that the kids will observe as they stack their cups. All right, let's go to another version of this. The second version, I've actually linked these in here so that you can go to them, and trust me, I'm only giving you a couple of these, but there are so many out there. I thought these were good. So Mr. Orr is a geek.com is this one, Stacking Cups. This one's 2014, so it's still pretty old as well, and he links to Dan's Stacking Cups lesson. And he's saying he doesn't know who came up with it first. But you know what? I think, honestly, way back, it may be the year 2000 even, there's some Tex Teams activities from Texas. And I think they have one very similar to this in there. And maybe Laying the Foundations, which is another organization in Texas. They might have come up with this too. So Dan's probably not the first to do it, but he's definitely the most famous one doing it. Now, here's an example of how kids might stack the cups. And then you could talk about, would this change the outcome? And of course it would. Or we're going to stack them like this. So you could actually come up with two separate problems here. I thought that was pretty interesting. And then he's got all these wonderful questions. Notice how he's using mini whiteboards. I actually do that as well. Because I'm having kids take pictures of their work and insert it in their slides, they are way easier for me to read if they're putting them on whiteboards with marker. So that's one strategy. He's also using the Desmos calculator. He's uncovering some misconceptions here, so you'll want to read about that. And then they'll go on to use their model to verify, and here they are stacking the cups to be the height of their teacher, which is kind of fun. I don't know about you, though. I don't know if I have enough cups to do all that. You may or may not be able to do that. We'll see. They have video in here that you can view, and wow, look at all the standards you can hit by this one activity. So you think you're eating up a lot of time, but what you're really doing is covering a lot of standards in a very interesting way. All right, and then there's a third activity here, and this is a Desmos activity of that same problem. And to be honest, this is probably the least interesting, but if you don't have the materials to do a stacking cups problem, this might be a good option. This might also be a good assessment. Maybe you could do a little mini assessment later on, a few days from now, and let this be like your performance task in your assessment. But they've got the measurements already there, so the kids aren't having to measure, and then they can just put what they notice and wonder. And then here they're filling out a table. Part of the table is finished, so they just need to give the last two measurements. They're going to follow that pattern, of course. And then here they're going to talk about stacking 10 cups. And will it be twice as tall as 5 cups? Agree or disagree? And then they'll have to justify their answer. And then finally they need to give the height of 10 cups. These answers should already be in here from the previous screen. And then they can check their answer. And then finally the graph. And then how could you use this graph to get 10 cups? What about 12 cups? You could copy this activity, modify it, and change 12 cups to like 1,000 cups or some crazy number, something they couldn't actually just count up to and get them to use their model. So this is a very basic Desmos activity. Totally do not recommend you do this one and not do the other two. I'd do one of the other two, and then this could be something you do later as a mini assessment to see how much they remember. Now I did provide a different stack of cups in their slides, so let's first go through the slides. The first few slides I intended you to use these with your actual activity or initial activity stacking cups, maybe the one you did with Dan Meyer, but just know you may not want any of this. I mean, if you're going to follow what he did with Fidelity, you probably don't want to put too much text and too much information. The goal is to get this out of the kids instead of providing it. So just use this if you decide to. That's great, but no, you can always delete slides that you don't think will work for your situation. So what I had here is I'm going to give them a stack of cups in teams. They would be seated with their teams, and usually teams of 3 and 4. They will have their stack of cups, and they have to type something. So what do you notice? What do you wonder? They have to ask at least one question, and then tell me at least one thing you know about these cups. And at that point, they don't have rulers in their hands, so they are not going to be able to give me numbers necessarily, but they should be able to tell me something about the cup. It's got like this lip on it, it's white, it's small, or whatever. I would probably use styrofoam cups, but there's lots of different types of cups you can use for this activity. Now this second screen, I would hand them all. I would give every team a yardstick or ruler, probably a ruler and a yardstick, and I would ask them to measure it. Notice I did not ask them what unit of measure to choose, so they may choose whatever measurement they want. So they could measure in inches, or they could measure in centimeters, and I do have yardsticks, actually meter sticks with both on there. Now the stack does contain, I think I gave every team like 6 or 7 cups, I forget. So it just depends on how many you have. I would say a minimum of 3 or 4 cups to make this really work is necessary. But just use your best judgment and whatever resources you've got. So if you don't have enough cups to give them that many, just give them what you can. And then I did give them a table. Now here's where I'm giving a lot of scaffolding, so this is where you may or may not want to use these slides. So we kind of want them to come up with these ideas of making the tables and doing that. I often have kids do problems like this on poster paper, not digitally. That way they're not necessarily going to Desmos and creating equations and doing it that way, because I really don't want them to. I want them to actually play with the numbers without their calculator and try to make sense of what's happening. And here's one, definitely a lot of scaffolding. So again, you may want to delete this slide, but it's saying here how many, the cup has how many parts. Well, that's kind of a weird question, because they're thinking it's just one cup. What do you mean parts? Well, if you look closely at the cup, there's like a lip on the cup, or there's something different about the top of the cup and maybe the bottom of the cup. like these red Solo cups that I have in a next assignment. It's actually the bottom of the cup that's kind of determining how far apart they are when you stack them. And then I'm asking which part affects the height of the cup when one cup is added to the stack, and explain. So I want them to examine the height, the rate of change in the height. So that's kind of the key. If you're using these slides and you don't want the scaffolding in here, you can delete these question marks. Just get rid of this and get rid of this and get rid of the number of cups, the X variable, and just leave the numbers in there, and that's fine. Then on this one, I'm asking them to create a graph equation, and I'm asking them to use their equation to predict the height of 100 cups. So that would be my question. You could actually just do the whole activity and not even go into the slides and hand them this on paper at the end and have them maybe show you what they did. I want to show you some of the notes I put in for the kids down here. Like here I said label the units. And these are some notes out here. Watch closely as you add one cup. How much is this height increasing and what part is making that happen? Here I asked them what unit of measure is in this table compared to the unit they had on slide 3. This is to make sure they're paying attention to the units when they're measuring the height to fill in the table. And they're not just using the same unit. Let's say they were using inches on slide 3, then on slide 4 we don't want them using inches. We want them using centimeters at this point, because that's what we're asking for at this point. But again, you don't have to. You can stick with inches if you want. And then this is the conclusion of this activity. So I would have them take a picture of their work and put it on this slide. Now this next part is a different cup. So let me pull this down. This different cup is stacking, and it's going up a lot slower, but I've actually gone ahead and given them some equation for this stack. Now you could ask them what these numbers mean. I did not do that, but I did want them to use function notation for these questions. So we're basically pulling back in our function notation and using it in this context. So what is h of 5 and what does that represent? Show how you can use the equation and insert a picture of your work on this slide. So I just wanted to give you an example of this work. This is a mini whiteboard that my students had. I had a whole class set of these in the room, and so they often wrote things on their whiteboards and took pictures of them and inserted them in their slides. This will only work if their cameras on their Chromebooks are enabled. Some districts are picky. They turn that stuff off, and I understand why they might do that, because it does get into some liability issues at times. But if you have the ability for your kids to take photos of their work on whiteboards, it sure does make your job easier when you're looking at their work on their slides. Taking pictures of pencil paper work with pencil, it's so hard to read that pencil when you're putting it on a slide like that. So this is why I went to the whiteboards, and once I did, the kids they enjoy it. It's a different way of showing work. They don't typically do it in their other classes, so it's something different that makes it a little less painful to do this type of work in math class. All right, and then the same thing on the next slide, except we're going to go in reverse. Now we have the number 10.75, and we know h of x is equal to that number. What is the value of x, and what does that number mean in this context? And they'll paste a picture of their work on the slide. I'm not sending them to Desmos to do these problems. I'm hoping they won't go to Desmos to do these problems. My goal is to get them to try to work these out manually. Some will go to Desmos. Some need the calculator just to do the most basic arithmetic. That's okay. There's nothing wrong with that. But I definitely want to give them that opportunity to do it without the calculator. So I'm not going to suggest it. And I'm going to encourage them to try it first before they go to the calculator. And then finally, what is the height of 100 cups? How would you find it? Insert an equation and the work that you did to get the answer. So even if they do go to the calculator, I would ask them, show me step by step, how could you get from this equation here to the actual height of 100 cups? Show me how that works. And then finally, the last few slides are where you're going to go to GeoGebra and work some modeling problems, and then they will copy paste their work from that slide or from that application to these slides. Now on GeoGebra, they're going to go into this screen. It's going to give them a scenario here at the top, and they're going to model this scenario with an equation. So this is probably the first time we've gone directly from words to equation in the class. This is technically something I think they probably should know it from 8th grade, but not many will. So they will need to take time to do this. So suppose you currently have $2 and you are earning $17 every 2 hours. Well, that is a rate of change, dollars per hour. So they can use that ratio, 17 divided by 2, as their slope of their linear equation. So I'm going to go ahead and type this in. And what's cool about this problem is they can really type it in any way that they want. If it's equivalent, it will accept it. So I'll show you what I mean. So they start with $2. The total is going to have the $2 in there, plus they will earn more, so they're going to get $17 divided by 2. So that means each hour is half of 17. So dollars per hour. And then they'll put the X for the amount of time from right now. All right, now when they click out here, the word correct is going to pop up, and it does convert that into slope-intercept form. Now, assuming this continues forever or indefinitely, what would your balance be after 30 hours? Well, at this point, they're evaluating. So they're going to take their expression, and I'm just going to type it directly in the blank, 17 divided by 2. We're going to evaluate that at 30 hours, and then they will add the 2. Or do it the other way, 2 plus 17 over 2 times 30, and then they will hit enter. So for this third part, we're going in reverse. We know the output, we need the input. So they could write this down on paper. We use mini whiteboards a lot, so my kids would have put this on a mini whiteboard and worked it out. Or they can actually do it in the blank, but it's more challenging. So I'm going to do it in the blank, but just know I wouldn't expect kids to necessarily do it in the blank. So the first thing I would do is take off that $2 that was added. So that 937 would be 935. And then I would divide that by 17 halves. So if you're going to divide by a fraction, you definitely want to put it in parentheses. Or they could convert it to a decimal if that's easier. And then they will hit enter, and it will say correct, and it will actually give you the dollar or the time amount. The time is 110 hours. And so when they're finished with this, they will screen capture that and put that on their slides. And then the new problem, when they click here, it's going to erase all that. So they need to make sure they've got their screenshot, which, by the way, there will be a kid that hits this before they take the screenshot, and they're going to be mad. But tell them to be careful. Don't do it until you've taken your screenshot, and then you will click new problem. So that is all. I do suggest that you spend time on this. I do have it scheduled for 1 or 2 days. You could technically take the original stacking cups problem and take an entire class period. You could do extensions with that. They could create posters with that. It's a very rich task with lots of things that you can discuss, and we'll hit on many, many standards. So I put one standard next to this in your guide, but just know that's just one standard. There's quite a few that are being used in this activity. If y'all have any questions, or if you do this activity with your kids, please share pictures and comments with me. I would love to hear how it went, and if you changed it up or switched it up in some way to do something interesting, let us know. I can add that to these materials for other teachers to enjoy. Y'all have a great day.